In this video, we're going to look at what it means for a function to be even or a function to be odd and how exactly we can show that. So first, the definitions here. Okay, so the definition of an even function is that if f of x equals f of negative x for all x in the domain, then f is an even function. So in other words, an even function is symmetric about the y-axis. So if you were to reflect it over the y-axis, if you looked at the mirror image over the y-axis, it would look identical. Okay. So maybe first function that maybe comes to mind would be x squared, right? F of x equals x squared. This is a function which is symmetric about the y-axis, so it should be an even function. So let's go ahead and show that. So if f of x equals x squared, then we look at f of negative x, which is going to be negative x squared. The negative gets squared too here because x is squared. So if we're doing negative x, we replace the x with a negative x. So this is negative 1 squared times x squared, and negative 1 squared is positive 1. So this is x squared. So f of x equals f of negative x, so this is an even function. Okay. Another example, f of x equals the absolute value of x. Okay. Again, f of negative x equals the absolute value of negative x. One property of absolute values is that this is the absolute value of negative 1 times the absolute value of x. Absolute value of negative 1 is 1, so this is the absolute value of x. So we can see that these are both even functions, okay, because f of x equals f of negative x. Okay, so now an odd function, if f of negative x equals negative f of x for all x in the domain, then f is an odd function. Okay. So, in other words, an odd function is symmetric about the origin. Okay. That one's a little bit trickier to visualize. So we're a little bit more reliant on the math on this one. Okay. But a good candidate for this, so let's just look at f of x equals x, right? Then f of negative x equals negative x, which is equal to negative f of x. Okay, so this is an odd function. Similarly, f of x equals x cubed. Okay. Here, so what we do is we find f of negative x, and then you could separately find negative f of x and show that these are the same thing. Okay. So f of negative x equals negative x cubed, which equals negative 1 cubed times x cubed. Negative 1 cubed is negative 1. Okay, so this is negative x cubed, and negative f of x is just negative x cubed. So these are the same thing. Okay, so they don't always come out to be the same thing. Like if we look at x squared again, okay, then f of negative x would be negative x squared, which we already showed was x squared. But negative f of x is negative x squared. Okay, so again, going back to the difference between negative x squared and negative x squared, right? Sounds like the same thing, but in the first case, the negative is being squared. So this one is negative x squared is negative x times negative x, whereas negative x squared is negative x times x, right? The order of operations is different here. The negative is not being squared in the second case. So these are not the same thing. So f of x equals x squared is not an odd function.